This is the second half of our Chapter 6 review. If you remember, the first half of Chapter 6 dealt mostly with parallelograms. And so right here I have listed our properties of parallelograms. The definition is a quadrilateral with both pairs of opposite sides are parallel. And then our properties where opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect. So let's look at 6.4 here. This was properties of rhombuses, rectangles, and squares. We are asked what value of x makes each figure the given special parallelogram, and then we are to justify our answers, of course. So the first one here was a kite. That's not a rhombus, rectangle, or square, so we get to skip that one. That one belongs in 6.6, so I imagine we'll see something like that later on. So our first problem here is a rectangle. And so what do we know? We are looking at the diagonals, so we want to find properties of diagonals. Hopefully you have your classification chart completed and in front of you so that if you don't have them memorized, you can look this up. So let's see, a rectangle. Well, the first thing we know is that for a parallelogram, the diagonals bisect. And then we also know that in a rectangle, the diagonals are congruent. So when we have two pieces of string that are the same length and we cut them in half, that means that those are going to be congruent. So we can say that 3x plus 3 equals 5x minus 11. And then it's just a matter of algebra here to find the value of x. So 14 equals 2x divided by 2, and x equals 7. So that value of x will make these the same. If I put that in, that's 21 plus 3 is 24. And this is 35 minus 11, 24, which is exactly what we expected. All right, and how about a rhombus? Well, what do we know about a rhombus? We know that in a rhombus, the diagonal bisects opposite angles. So that means that this and this are congruent, which allows us to do our algebra. We can say that 4x plus 1 equals 5x minus 15, and then we just do our opposite operations. And x minus 15, add 15 to both sides, and x equals 16. This value of x will give us congruent angles here. So 16 times 5, that's 80 minus 15 equals 65. So that angle is 65 degrees. And 16 times 4, that's 64 plus 1, also 65 degrees. So yay, that worked out exactly like it was supposed to. All right, let's move on. 6.5. Conditions for rhombuses, rectangles, and squares. These were our converses. How do we prove that a figure is whatever it is? And what are we asked to do? Classify each quadrilateral as precisely as possible and justify. So what do we have on our first one here? We have both pairs of opposite sides are parallel. Do we have anything else? Nope. Best we've got here is parallelogram. We can't go any further than that. And next in line, let's see, well, opposite angles are bisected. Well, we should put diagonal. we should do this properly. Diagonal bisects opposite angles. Who does that? That is a rhombus. All right, and what do we have here? We have one pair of parallel sides. Only thing that does that is a trapezoid, which again is not a rhombus, rectangle, or square, but that's okay. We'll let it stay. I didn't look at these closely when I put them together. That's all right. Makes it more entertaining. Keeps us on our toes. All right. I bet you'll see stuff like this on the test is why I threw them in. What do we have going on here? Well, the diagonals bisect. So that's parallelogram. And what else is happening here? Our diagonals are perpendicular. So the diagonals bisecting tell us we have a parallelogram. The diagonals being perpendicular, what kind of parallelogram does that? Yep, you guessed it, rhombus. All right, what do we have down here? Our diagonals bisect. Our diagonals are congruent. And let's see, diagonals bisecting, that's parallelogram, so that's good. Diagonals are congruent, right? If we add them together, they're congruent. That means we have a rectangle, but our diagonals are also perpendicular. So that means we're going even more special. Diagonals perpendicular, that's rhombus. Who is rectangle plus rhombus? This is our friend, the square. This next one doesn't fit either, does it? Oh, well. We have consecutive sides are congruent. Who does that? Not a rhombus, rectangle, or square, that's for sure. This is a kite. Does not belong, but that's okay. We're just going to smile and go on. And this, we've got 4 congruent sides. Technically, we can't do anything with this because we don't know it's a parallelogram. But let's assume it's a parallelogram. 4 congruent sides would be rhombus. But technically, we can't say it's a parallelogram. We don't have that information. I need to pay more attention when I put these together. And here, diagonals bisect. Anything we can do with that? No, best we've got is parallelogram. All right, well, that was kind of entertaining because some of those didn't belong, but it was still good practice because I bet you might see some of that kind of stuff on our test. Let's go to the next one, see how this goes. For each parallelogram, all right, that's good to know. Each parallelogram, determine the most precise name and find the measure of the numbered angles, and justify. All right, who do we got here? We got a parallelogram with 4 congruent sides. 4 congruent sides tells us rhombus. So what do we know? We can do the measure of angle 1 is 50 degrees. How come? Because our diagonal bisects opposite angles. The measure of angle 2 is 90 degrees. So let's make that 50. Angle 2 is a right angle, right? Because in a rhombus, our diagonals are perpendicular. And so how are we going to find the measure of angle 3? I'm going to say triangle angle sum theorem because we've got a 90 here. So 90 plus 50 plus the measure of angle 3 equals 180. And I subtract 140 from both sides. Measure of angle 3 equals 40 degrees. So that's 40. And how are we going to find the measure of angle 4? The measure of angle 4 is going to also equal 40 degrees because the alternate interior angle theorem. Right? This angle here and this angle here are alternate interior angles. All right, who's next? Our diagonals are congruent. That means we've got a rectangle. So what are we going to do here? Measure of angle 1, that's 40 degrees. How do I know that? Isosceles triangle theorem. See the isosceles triangle there? And how am I going to find the measure of angle 2? Well, I'm going to say 40 plus measure of angle 2 equals 180. That's triangle angle sum theorem. So subtract 80 from both sides. The measure of angle 2 is 100 degrees. So that's 100 up there. This is 40 here. And how am I going to find who's next? Let's do measure of angle 4. That would be the one I would do next. Measure of angle 4 is 80 degrees. Linear pair postulate. Haven't seen that one for a while. You see the linear pair there? So that's 80. How are we going to find the measure of angle 3? Couple of ways we could do it here. We could say that this is 80, right, by vertical angles, and then we would know that those are congruent. We have an isosceles triangle. We could take our leftover and divide it by 2, right? That would be 100 divided by 2 would be 50 degrees. Another option here is this is 40 degrees because of alternate interior angles. And what do we know about the angles of a rectangle? We know that this entire thing is 90 degrees. So the measure of angle 3 plus 40 equals 90. That's just definition of rectangle, right? And so the measure of angle 3 is 50 degrees. So both ways like that work very nicely. Okay, what do we have going on here? We have nothing. So what's that going to do for us? This is simply a parallelogram. So how am I going to find the measure of angle 1? Measure of angle 1 plus 80 plus 55 is 180. That's our triangle angle sum theorem. And so subtract 135 from both sides. And the measure of angle 1 is 45 degrees. So if that's 45 degrees, and then how am I going to get the measure of angle 2? Yep, that's right. It's also 45 degrees, alternate interior angle theorem, right? Angle 1 and angle 2 are alternate interior angles. Measure of angle 3 is going to be 80 degrees. How come? Because opposite angles are congruent. So that's 80, that's 45. And the measure of angle 4, we have multiple ways to get that. We could do triangle angle sum, or probably the easiest here, it's alternate interior to that angle up there. So the measure of angle 4 is 55 degrees, alternate interior angle theorem. Okay. What do we got going on in the next one? We're moving through these pretty well. This isn't so bad. We've got diagonals or perpendicular. Who has perpendicular diagonals? Well, at this point in our learning, only a rhombus. So, measure of angle 1 is 90 degrees. Because either diagonals are perpendicular, or we could do linear pair postulate. I'm just going to go diagonals are perpendicular. That's the easiest. I'm going to move this up just a touch there. All right, so we've got 1 is 90 degrees. Oh, what else can we do here? We know the measure of angle 2. What's the measure of angle 2? That's right, 27 degrees, because the diagonals bisect opposite angles. So this is 27, and this is 90, and this is 90, right? Everybody here in the middle is 90. So the measure of angle 3 plus 27 plus 90 equals 180. Yep, that's our friend triangle angle sum theorem. And so 90 minus 117 from both sides. And the measure of angle 3 is 63 degrees. And the measure of angle 4, hopefully you see this by now, 63 degrees, alternate interior angle theorem. So there seems to be a theme going on here. Our properties and alternate interior angle theorem and linear pairs. Okay, who's next? Pardon me. What do we have here? We have congruent diagonals. I don't want to write it that way. I want to write diagonals congruent, because that's what our theorem says. Our diagonals are congruent, and we've got a right angle. So we've got a rectangle. All right, what are we going to do here? The measure of angle 1 is 116 degrees. How come? We haven't done these for a while, but you still need to know them. That's our vertical angle theorem. So this is 116, and the measure of angle 2 is plus 116 equals 180. That's linear pair postulate. So subtract 116 from both sides, and the measure of angle 2 is 64 degrees. So 64 degrees there. So now what's next? How are we going to find the measure of angle 3? Well, the measure of angle 3 let's take a look up here. Do you see this isosceles triangle here? So 2 times the measure of angle 3 plus 116 equals 180, right? That's just triangle angle sum theorem. And subtract 116 from both sides. And then what does that give us? 64, and then I'm going to divide by 2. So the measure of angle 3 equals 32 degrees, right? Because it's half of what's left over. And we're going to find the measure of angle 4 the same way. So 180 minus 64, guess what? That's 116. So 116 divided by 2, the measure of angle 4. Do you see it here? Our isosceles triangle. So we're going to do exactly the same thing we just did. Measure of angle 4, 58 degrees. So these are 58 here. Another way we could have done that is, I need a different color. This right here is a right angle, isn't it? And we know that this one is 32, so 32 plus the measure of angle 3 equals 90. 90 minus 32, that gives us the measure of angle 3 equals 58. So, multiple ways to do these things. Use your right angles to your advantage. We could do it both ways, isosceles triangle theorem or right angle. Use your right angles to your advantage. They're good. Remember, it's geometry. Multiple ways to do everything. All right, what have we got going on here? We have 4 congruent sides. That's rhombus. And I've got right angles. That's rectangle. Rectangle plus rhombus. We have a square on our hands here. So, how are we going to find this? This would be an excellent time. That's a right angle. So is this one up here. I've written over it a little bit. Those are right angles. And what else do we know? We know that the diagonals bisect the opposite angles. So the measure of angle 1 is 90 divided by 2, right? Bisected equals 45 degrees. And the measure of angle 2 is 45 degrees. Either for that same reason or also alternate interior angle theorem. All right, so that's a lot of good stuff. Use your right angles, use your isosceles triangles, use your vertical angles, linear pairs, and all the properties of your parallelograms. All right, let's move on to the next set. Trapezoids and kites. Finally, we've already done a few of these. That's all right, though. We got this. Find the measures of angle 1 and angle 2. All right, well, we've got a kite here. And what do we know? How are we going to find the measure of angle 1? Well, there's a few ways we can do this. But if you remember, I told you that the angle included between the non-congruent sides, they're congruent. So the measure of angle 1 equals 110 degrees. And the actual reasoning for that is we've got congruent triangles and CPCTC. Okay, but nonetheless, still 110 degrees. We're told this is a right angle here. So what did I tell you about these? We said that the angle included between the congruent sides is bisected. So these two are congruent. So what could I say about them? And say this measures 45, this measures 45. Right? Because that's bisecting that right angle. So how am I going to find the measure of angle 2? Measure of angle 2 plus 45 plus 100 equals 180. That's our triangle angle sum theorem. And so I subtract 145 from both sides. And the measure of angle 2 is going to be 35 degrees. So that wasn't too bad. All right, we've got another kite here. Stop moving. Stop moving. The measure of angle 1, 90 degrees, because in a kite, our diagonals are perpendicular. So that's 90 degrees. Means that's 90 degrees. How am I going to find the measure of angle 2? Plus 90 plus 67 equals 180. Our friend triangle angle sum theorem. And we subtract 157 from both sides. So the measure of angle 2 equals 23 degrees. Good stuff. Oh, and something different. Yay! We've got an isosceles trapezoid here, right? So how are we going to find the measure of angle 1? Well, the measure of angle 1 plus 70 equals 180. Because same side interior angle theorem postulate. Theorem. We'll go with theorem. That's why we have our notes, right? So subtract 70 from both sides. The measure of angle 1 is 110 degrees. So this is 110 up here. And what's the measure of angle 2? Measure of angle 2 is 70 degrees because we've got isosceles, which means our base angles are congruent, which means we could put 110 up here as well. This is 70 degrees. So those were pretty easy. All right, what's next? Ooh, this looks like a touch of the triangle mid-segment theorem. What is the triangle mid-segment theorem? It says that the length of the mid-segment is 1/2 of the sum of our bases, or my preferred method, 2 times the length of the mid-segment equals the sum of the bases. You can use whichever one you like. I prefer to multiply by 2. So let's go ahead and do this. We wrote our formula, 2 times, what's the length of our mid-segment? X plus 3. Make sure you're using parentheses because that is a single idea. Equals base 1. I'm just going to call this one base 1, this one base 2. X minus 2 plus 2x. So now don't forget, distribute. So 2x plus 6 equals 3x minus 2, just combined like terms. Now I'm just going to use my algebra, and we get 6 equals x minus 2, add 2 to both sides, and we get x equals 8. So I'm supposed to find the length of EF. Well, the length of EF equals x plus 3, and I'm going to substitute in my value of x. The length of EF is 11 units long. So this is 8 plus 3 is 11. 8 times 2 is 16. 8 minus 2 is 6. Guess what? 22 divided by 2 is 11. We did good. This isn't going so badly. All right, because we are on our last problem here. And give the most precise name for the figure. Well, the first thing I'm going to do is write the coordinates of my points here. Point A is at -3, -4. Point C, because it goes around, it doesn't go in order there, does it? Point C is -2, 3. Point B is at 5, 2. And point D is at 4, -5. All right, well, how do we name figures? We need parallel sides, perpendicular sides, congruent diagonals, perpendicular diagonals. So I'm thinking some slope formula and distance formula here. So the first thing I'm going to do is the slope formula. So m is y2 minus y1 over x2 minus x1. And I'm just going to start here on AC. The slope of AC, A to C. And I recommend labeling your points, x1, y1, x2, y2. I'm not going to because I'm going to use them a lot here. But 3 minus negative 4, if you do it, your life will be better. Minus 2 minus a negative 3. Notice it's always minus. Watch those negatives. So this is 3 plus 4 is 7. Negative 2 plus 3 is 1. All right, who's next? Slope of CB. Let's just do CB. That's 2 minus 3 over 5 minus a negative 2. 2 minus 3 is negative 1. 5 plus 2 is 7. Ooh, I'm seeing some good stuff happening here. And let's do BD. Just do the next one. BD is negative 5 minus 2 over 4 minus 5. That's a negative 7 over negative 1 is a positive 7 over 1. And last one, the slope of AD, negative 5 minus negative 4 over 4 minus negative 3. Negative 5 plus 4 is negative 1. 4 plus 3 is 7. So what can we get out of this? We've got these two are going to be parallel. So AC is parallel to BD. And check it out, these two are parallel, right? Same slope is parallel. So segment AD is parallel to CB. So this is going to give us, we've got AC is parallel to BD and AD and CB. So we've got a parallelogram. This tells us parallelogram. But our slope tells us even more than that, doesn't it? What else does it tell us? It tells me we've got opposite reciprocal as well, don't we? Who's opposite reciprocal? Well, AC is perpendicular to who? AC is perpendicular to CB. And CB, so AC is perpendicular to CB, so we've got a right angle there. And CB is perpendicular to BD, so we've got a right angle there. And BD is perpendicular to AD, so we've got a right angle there. And you guessed it, AC is perpendicular to AD. So we've got a right angle there. So I have 4 parallel sides and 4 right angles. Now I've got a rectangle. Or I've got opposite sides are parallel, gives me a parallelogram with 4 right angles is a rectangle. What's the next thing we can do? Well, our only other option is we could possibly turn this into a square, right? It kind of looks squarish, doesn't it? We don't get to assume anything, but it kind of looks like it could be a square. So how do we prove a square? Well, we need some square properties. So we need some properties of rhombuses. What do we know about rhombuses? Well, we could either look for 4 congruent sides, right? So that would be distance formula. Let's look like the length of AC equals x minus 2 minus -3 squared plus y 3 minus -4 squared. So that is, move this up just a little bit here. That is -2 plus 3 square root of 1 squared plus 3 plus 4 is 7. Is that right? Yeah, that's right. 3 plus 4 is 7, so 7 squared. So that's 1 plus 49. It's a square root of 50. And then I could do like CB, length of CB. So that is my x's 5 minus -2 squared, my y's 2 minus 3 squared. You can already see it's going to come out, can't you? Minus 2 is the square root of 7 squared, plus 2 minus 3 is -1 squared. Don't forget you're squaring a -1. So this is the square root of 49 plus 1 equals the square root of 50. So we could say that these two sides are congruent. What do you want to bet if we do the others? They're congruent as well. Another option would be, are our diagonals perpendicular? Right? I bet we could make our diagonals perpendicular. So I would find the slope of CD, and that is -5 minus 3 over 4 minus -2 is a -8 over 6, which is a divide by 2, -4 over 3, and the slope of AB is 2 minus -4 over 5 minus -3. 2 plus 4 is 6. 5 plus 3 is 8. Divide by 2 equals 3 over 4. This makes our diagonals perpendicular, right? That would be a rhombus as well. So if we did all 4 congruent sides, that's rhombus. Perpendicular diagonals is rhombus. So in the end, we have a parallelogram, which we established at the beginning, that is a rectangle plus a rhombus, means we have a square. So, yay, that's a square. Many, many ways to do this. I didn't complete the lengths of the sides, but your slope formula tells you parallel and perpendicular. Your distance formula gives you the length of sides, the length of diagonals. We could have done that too, couldn't we? We could have done the lengths of our diagonals, would have given us congruent diagonals, which would mean rectangle, but we already knew that. Just check. Find the best way that uses the least amount of work. Slope formula is easy. Write out your points. I highly recommend labeling, x1, y1, x2, y2. All good stuff there. So have your classification chart. Make sure it's filled out. Make sure it's easily readable. Make sure you have studied it so you know what you're looking for. And don't forget all of the things that we have learned, because we have parallel lines, which means special angle pairs, most often alternate interior angles and same side interior angles, and our triangle angle sum theorem. That is a fan favorite. And vertical angles and linear pairs have been our friends for a long time. So just make sure you study, and I really believe that you will do very well on this upcoming test.